Right, so my name's Stephen Baines. I'm in the TWI team. I'm presenting work on behalf of TWI and Lancaster for our various compadres. So I'd like to start with some questions here, following on from what Chris was saying. Do our education systems condition us to address problems in the wrong way? Traditional business evaluates things in a complex review process to derive go, no-go decisions. This is a good and proper means testing of a business case. But if the business case is valid but perhaps not affordable, the natural conclusion is there's no money. Instead, if we ask, how can I afford it? There is a mindset change. And there are massive complexities of running SME companies. So if you've got a limited, this is for UK, but it translates. If you've got a limited company and another limited company, they can trade between them, so you can make great savings that way. But in our artisanal case, do we require those manufacturing changes? What categories should we consider? So I've kind of just tailored it down to 3 possible production working changes. So in one, artisan production, maintaining an artisan ethos, but perhaps adding in a slightly different approach to the production process. In 2, artisan production tending towards increasing production / improving validation of quality control. And then 3, changing from an artisan production, perhaps for a new market, or a change in production to contain no artisan components. And we have one case where a production scenario was to introduce a new product that has mass market appeal, and they wanted a different way of implementing that market. So it may also contain a mixed mode, so 2 production streams, one considering high effect artisan components, and the other one more of a mass market approach. So in our case studies, in several of the following examples, the developments have changed from a traditional approach. It doesn't mean that either is right or wrong, they're just a different method. In most cases, the proposals to do this were harmonious, symbiotic, extending capability, upskilling the workforce, and their working relations. The following slides show the concepts considered. The company names have been changed to protect the innocent and stop Torsten suing me. And there are only 4 examples of our 9 case studies. So these are they. The left-hand column clusters, so we've got Milan, UK and Germany, then the company where the names have been changed, and then the technology where they're working in. So smoking equipment, writing equipment, brass wind instruments and flame burner technologies. So in the first case, which is Golden Briar, they are making pipes from briar wood. It takes 5 years to dry, 2 months of production, 90 production steps, and they were looking at implementing CNC production, possibly linked to vision systems, so that people could dial in and see their product being made live real time. So they also wanted to offer customers the opportunity to modify STL files, CAD files, to input into their own product and turn it into a particular bespoke offering for them. And they wanted to build in RFID to protect their brand, particularly from Chinese markets copying their product. So in the middle picture of the bottom is a laser scan through a GOM system, which has been then converted into an STL file. So it's scanned the base briarwood before it's been machined, before it's been finished. And then that has been used to create a blue picture in blue on the left-hand edge. And then this is where the RFID lozenge would be put in. And then we were sending this part, which was the wooden part, of course, and it was having CNC holes drilled in. So the CNC drills were to place 6 thermocouples at different heights and positions within the component. So then that was measured. So then a machine smoked the pipe, which produced lots of horrible stuff. We want to go on there, but it proved that RFID wouldn't survive inside the pipe with that position. So that was changed. We couldn't progress with that any further. So then the notion was proposed, well, can we put some identify marking on the pipe that would be verify instead of an RFID? So if we had something like a QR code, you're used to seeing QR codes now, that's the kind of the data format of a QR code. The various areas that do the programming side of things, but could we build that into the surface texture of the pipe, possibly using perfect circles, because we can machine circles. It's much harder to machine squares, so it's never going to be the same as a QR code, but could we embed data in the surface? So we can see that the artisanal approach is this blue arrow going over the top, where a person's actually taking the briar and then processing it on a machine. So they're hand processing it to get this stippled effect, and this is their most sold product in terms of the surface finish. So could we make a system that goes through a scanning computer with a bit of AI in it to create these perch points that are a normal vector to the surface, that then creates a certain amount of randomization code and then spit that out to make a surface. So then that surface has then been analyzed. So in this case over here, we start with a JPEG, which is then converted to a grayscale picture. That picture, which is about 1 inch by 1 inch, is then converted into 400 smaller pictures, and then the scanner finds the edges to form this fingerprint identity. And out of the 400 images, this is the noise at the bottom, there is only one image that matches the 400. So it's a really important validation approach to creating a surface that can contain data. Of course, that just going back to that process. Just going back to that picture. This algorithm that can be built into this can build the texture and build extra code into that data. So by the time the surfacing concept was available, the pipe company had positioned itself closely with the Chinese markets and therefore didn't see such an issue of the RFID any further. But they were interested in the CNC machining of the briars, which could be considered by 2 robotic handling machines. So one holds the briar and the other one textures the outside. So there's a proposal that we could also do this on metallic surfaces where the surface is not ground, but we use laser to manipulate the grain structure of the metal to embed a detail that can't be seen by the eye, but only revealed by surface etching or an X-ray. So that could be a really important finding for the project. In the next case, which was Prestige Ink, so we can see a nib over here and the nib tips. So we were looking at a way of identifying whether a nib could be imaged in a way that we could determine whether it was going to write nicely. One of the tests for the company was to use paper, write on the paper. Does it feel scratchy? Does it flow smoothly? And that would determine whether that nib went on to the next stage in the process. So we're using interferometry and alloconer microscopes to do this. So this is a picture of an alloconer microscope image of the tip. It's built through a light layering to map a 3D image. which then can you get a height profile. But it's easy for an operator then to see the complexity of the surface and whether it's got any digs in it. So easy for human visual assessment. This is an interferometer picture looking at the nib, and it's looking end on at the nib. And what we can see from this smattering of data points is that the nib heights are not the same. Therefore, this nib is going to be more scratchy than ones that have nibs that are the same height. This is using the interferometer again to look along a barrel. So this is the barrel of the pen. It's in green, and it's got these micro digs in the surface. So this picture is showing that the barrel is generally barrel shaped, and this one's showing that there are significant digs in the surface. These digs can then be conceptualized, extracted from that data to say that there's no, this wouldn't pass a quality control assessment. In this version, there was these are high-end barrels now. They're incredibly expensive machining, and but they are machined, and there can be errors incorporated in the pattern as the tool wears. So the allocator microscope has created an output. It creates a picture, which is a height map, and then the height map is determined by the software. So we also saw that they had used laser engraving, but they weren't using it in this case, and the laser engraving would be much better approach than using this machining method, because it was giving such a high rejection rate. So we proposed a method of testing barrels, whether they're the machine ones or the polymer versions. The barrel is placed over a mandrel with a stepper motor, and a line scanner looks at what's happening on the surface, and numerically controls what data it sees to form a pass or reject scenario. So in this version, which is a Cornet company, we were looking at producing or trying to redesign all of this and many parts of the Cornet in particular. So in this first case is the insert valve, which goes in this body. So there's 3 insert valves, and they're all different, and they're all taking sound or passing air in a different way to make the sound. So we're also looking at converting this to be machined from a monoblock piece of brass, rather than being made up of 19 different parts which are brazed together and later soldered together. So we were trying to develop this. There's lots of complexities in these parts. These are hand assembled, to get rid of the hand assembly and make it as one part that we could print by stereolithography. So that was printed in polymer to trial in the musical instrument. So there were positives and negatives of using the polymer. One is that it's very lightweight, it's low cost compared to the manufacturing, much lower cost. And the airflow was good, but the feel in the instrument was bad. And that was because it was so lightweight that the response was very fast, and it was just different from the original processing conditions, which was perceived by musical players as a negative. There would be opportunity to balance that with different spring responses. So we also tested printing in lots of different types of polymer, printing in the UK, printing in China, looking for cost comparisons and material advantages. And we also just redesigned the Cornet overall, so it could be made with lead-free solder, and that would be the first time that was would be possible, and also to use mechanical fixings for ease of repair. How long have we got, Chris?
5 minutes until questions. And then
Yeah, right. Thanks. So in this case, we were looking at burner technologies for Lloyd. We can see in the breakout image a burner that was developed for the project, which is a hydrogen burner, essentially. It's a surface mix burner. So Lloyd wanted to investigate additive manufacturing. So this is 3D printing in metal. But when they saw the scale of the plant, the complexity, that became a no. But what was of interest was water jet cutting. We did lots of trials in water jet cutting, laser processing, laser cutting, laser welding, and these were of particular interest for making hydrogen burners. So that's what we took forward and did much investigation around that. But how do we start? We started with the finest detail that we'd have to look at, which was processing the square tubes that go into making the hydrogen burners. So an average radius of 0.2 millimeters. Could the water jet cutter actually achieve this? So in the end, Lloyd bought this Omax water jet cutter, a much smaller version than ours. They also bought a laser spot welder, which gave them a new technology to make burners in a different way. With the new design processes that were possible and processing conditions, we were able to use circular tubes instead of round tubes instead of square tubes, which was a massive cost reduction. We also did a bit of robotic braze pasting, which led on to trials with vacuum furnace processing, which was an incredibly good technology. We start from having a component with high oxide layers, and when it's processed in the furnace, all the oxide layers are removed, and it gives a perfect braze component as well. Metallurgical assessments were done, which also validated the production process. So in this top picture, we can see the robot applying a braze paste, and these are our production jigs that we used in sort of mini production runs to validate the assembly processes. So in our product placement, so there's three possible, we mentioned at the start, the three possible artisan production types. So in number one, we've got Golden Briar and the Cornet company for their high cost versions, which are lower sales. But in number three, we've got Cornet Co. with their lower cost versions, which are more mass market sales. And in the middle, Prestige Inc. and Lloyd. So how are we doing, Chris? Sorry.
Got 1 minute left until questions.
Right. So we were engaged. So the lessons learned then. So the findings for Golden Briar, it was a fantastic technology. It could assist the technology scale up. And with Prestige Inc., high visual quality assurance, product improvements and automation processes could really have helped their company. Cornet Co., we've looked at new models, expansion of global markets, elimination of lead, and investigated machining with 7-axis machines. For Lloyd, the options were the finished quality of the upgrades, a parametric design, looking at a single torch design through computer-aided manufacturing, which could be scaled, easily scaled. So the findings and ethnographic influences. The ethnographic insights revealed that a successful transition to Industry 5 in manufacturing is not just an adoption of new manufacturing technologies, but on the equipment equipping the managers with the skills to understand and support and collaborate with their workforce. Managers stroke directors play a pivotal role in aligning the technological changes with the company's craftsmanship values and long-term goals. By investing in managerial training and emphasizing human-centered practices, companies can achieve a balance between digital innovation and transitional skills. These observations showed that the training extended beyond formal instruction. It includes the learning by doing, experimentation, and cross-departmental collaboration. This approach helps preserve the product quality, maintains a collaborative workplace culture, and strengthens the company's competitive edge, positioning them successfully for a rapid evolving market. In most cases, the solutions were not apparently affordable, as per our intro point, but where implemented, a new level of design freedom was experienced. The designs and process validations have been completed, international markets assessed and materials tested, improved manufacturing results demonstrated, new methods developed for embedding surface data, toolpath and CAD for robotic translation were much more complicated than necessary, leading to an external funding application to address the requirements. Thank you.
Yeah, so when I said we were working with engineers, I really meant it. Right? So, questions for Stephen?
You insisted on that managers needed to have this capability to work with workers and those kind of things, but that was not really apparent from your story. So maybe you have some examples how that worked?
Yeah. So I can tell you some of the negatives of where that was applied. So in some cases that was it was very apparent that people wanted to implement new technology for the removal of roles, but where in companies that were looking to augment technology for the benefit of their people, their outlook is much better.
What also struck me was in several of the pilots, there is this kind of experimentation to find out China and local production. There was not one case with the US. But how do you see that? We should continue like this, have this collaboration?
Are you asking about China in particular, or how would it change if we went to the US?
It seems as if China is a good partner to work with certain things, sometimes not, just to make sure that not everything is copied. But you have the resources there that you need to make the products that you want in Europe. But yeah. I haven't seen one of the cases looking at the US for capabilities and those kind of things. So maybe there aren't the capabilities that we need. And so if we have our future economic development, our eyes will be continuously focused on using China and collaborating rather than...
Yeah. Okay, thank you. So this wasn't about particularly using China. This was trying to evaluate the lowest cost means of producing the insert valves for the valve monoblocks. So we weren't being driven by, are we going to manufacture this in China? It was to get a cost comparison between what we can do in the UK and what can be done in China. And we were testing different types of polymers that could be printed. Now, Cornet Company were interested in having valves inserts in metals as well as polymers. But to do a validation process, it was much lower cost to actually go through a polymer processing route. So we tried lots of different polymers, and the one that you saw on the screen was printed in China. but it had very slight micro distortions in. So while it looked really good, by the time we actually had to machine it back, it became more expensive than anything that was made in the UK. So while there were other ones made in China that were acceptable, the ones that we got in our local fab house, you just send an order down the road and it comes back next day, they were not as good as our own production tooling. Chris?
Thank you very much. It was really, really interesting. And I'm curious, when you're talking about the validation process and the quality management systems that you didn't talk about, but I'm curious because you sort of referred to it throughout the talk. In terms of one of the questions I had has to do with the defects and the training. So my interest was then, and this will link with whether or not production is done with China, because, and my curiosity has to do with what are the measures for validation that are approached, and because there's going to be certification schemes. Because the reason I'm asking is because there are a whole range of new standards being introduced, of course, but that has to do with AI. And I think you'll be relying more on the existing standards in order for that to happen. So my curiosity is, which ones are you having to use, and go through that. And then second question has to do with where there is bits of AI, and so where production happens, and how do you make the decision of which bit of regulation are you going to follow, given that exists?
Right. So let's. So we're talking about artisan products being validated on the shop floor. So in the case of our Italian cohort, they were, as far as I'm aware, they weren't working to standards. So it's a case of visual acuity. So they wanted a means of assessing visually better than having two ladies look over it.
And that's going to pass any inspection?
Well, it didn't pass because there were products, you're paying 50 or 100,000 pounds for a pen.
Okay.
They would be sent back because they had apparent defects.
Yeah.
So you're saying the customer is using a microscope to prove that there is a defect. That's the kind of thing that they were up against.